Hello everyone. Today I'll be presenting a paper titled Computational Policy Analysis for Public Administration. It's a modeling case, specifically agent-based modeling in innovation policy. My name is Bashar Ourabi. More important on all dynamics of economic space. The ongoing debate of public policy formulation all strategize makers need to evaluate a given policy. In this, a central question must be addressed: how the economic agents are directly affected by the policy expected to be. In the knowledge era, the creation of economic value is based mainly on intellectual capital and the ability to. Intellectual capital encompasses three interrelated components: human capital, structural capital, and relationship capital. Schumpeter recognized and coined the concept of innovation as an economic driver of competitiveness at the firm level. Later, a creative accumulation of non-transferable knowledge in specific technological areas and markets. This brings us to the set of research questions. How can incentive policy facilitate skill attainment by influencing workers' decisions? How can immigration policies direct skilled labor into engaging in the current economy? Question 3. How should the policy be designed to incentivize economic agents in participating in innovation? Question 4. How can incentive-based employment policies facilitate overcoming risk concerns with the brain drain of skilled labor? And question 5. How does the impact of a policy instrument differentiate between dominant and market players with an existing and new entering agents? Consequently, how is the policy instrument expected to affect the evolution of the market structure? Our methodology in approaching the modeling problem on hand is in line with Carney's methodology. You can see more details about it in the original paper. Now, our methodology was to dissect the different problems or steps in approaching the economic shift and movement for all the interrelated components identified in the literature review, and then linking them together in a two direction flaws. One going from, for example, as you see, we start by the final level, which is layer 6, and it's the individual attributes and behaviors. These individual attributes and behavior somehow contribute to layer 5, the one above it, the national products and the attributes and the behavior on a national scale. Of course, the bigger framework is the national framework, and within this framework lies the individual attribute and behavior of the workers. Both of these are also a part and a result of layer 4, the one above it, which is a governance and government and policy. And as you see, each one of these layers has a two or bidirectional relationship with the layer above it and the layer below it. This is a very imperative relationship, okay, for the modeling utilized in our model. So, while the individual attributes could be influenced by a specific policy. Also, the innovation setting, if we look at that as the final deliverable, is also a byproduct of these individual attributes. We have three different types of capitals, and all these capitals are actually working with each other, against each other, and in sync with each other. So we cannot concentrate on one of the subcomponents without affecting all the other subcomponents and the different type of capital. So this is the main concept where if formulation does not consider all different actors, if you wish, okay, perhaps we don't produce the desired outcome because we're missing an element where another element is working against us. Now, my personal approach in tackling this problem was to consider the literature review, yet I had to modify the components perspective to a programming perspective, because from an agent standpoint that considers, for example, three different countries, okay, we have three different countries competing for this skilled labor, for say. And if we have that, okay, we have to look at the same type of capital that we considered initially, but we have to set them in a different tier system or subclassification based on what we require the simulation model to do. I required that, for example, the simulation model to consider each country, and where I can play around with the worker types and at the same time introduce different type of policies into my simulation runs. So I've identified all the different subcomponents from the previous relationship slide, but I've redistributed them to exhibit what I As you see from this screen, we have three different colors demonstrating different countries with different colored people icons that demonstrate different type of skill set. Also, we have sliders here that are utilized to specify different initial conditions for the three different countries, and different inputs, for example, for the people as far as wages. We can control the flex initial condition for the markets at the three different countries. We can change unemployment levels for the three different countries. We can create resistance in the immigration, or friction if you wish, to simulate for different policies that restrict for immigration. So we utilize this in such a way that to capture how the different behaviors are actually being conducted at the entity level of the worker, and how these workers are migrating from one country to another to simulate, for example, the movement or the inflow of people. Yet at the same time, if we look at the different graphs here, we're capturing emerging behavior as far as wage setting, or how much is the pay for the different skill set at the different country. Also, we are capturing innovation as the key performance indicator, and how we are building this capital or actually reducing it or maintaining it at a specific set. So this model actually allows for a policy setter or a strategist to identify different initial conditions and try to test hypotheses for different policies. Now, the data theories that are utilized in my model originally are all based on scientific research finding. So I'm not setting initial conditions from random. What I'm actually doing is I'm identifying, for example, work bank data and placing it in my simulation model. And based on data theories on how these markets or how the behavior is supposed to be to be an output to be outputted. Okay, well, I try to see how these fundamental relationship between the different scientific findings could actually interact upon each other. What's the combinational output of these data theories? The table you see in front of you is a summarized policies that were utilized in our simulation model. Six different approaches were considered. One with no policy, second with immigration friction induced, making it harder for a skilled worker to immigrate from one country to another. The third, inducing, for example, demand. The fourth, wage setting policy. The fifth, a combinational policy for all different skill sets. And the last one was a combinational policy concentrating only on high-skilled labor. Now, the ones you see in the red, the boxes you see in the red, were the results that were considered to be counterintuitive. For example, we could achieve a high innovation KPI for a specific country, but it was noted that the inflation in the wages level was so high that the country could not be considered competitive. So what we were seeking here is to have somehow a balance between the KPI, the output KPI, and the emerging behaviors, okay, from institutionalizing the different type of policies. And the last one, number 6, identified that there is a possibility in increasing the innovation for the gray country in a reasonable short period of time, while maintaining the rate of income at a normal level. Okay, so in the paper, if you go to the appendix section, I've actually written complete reports that demonstrate the data. Now bear in mind that this data was considered very deterministic, because every time we run the data we're always going to come up with the same result. There's not really an input of randomness in this. But that's okay, because again, we're not trying to forecast a specific number here. We're trying to identify, or our concentration in this paper was to identify emerging behavior from different setting perspective. Okay, so perhaps in future papers we can get into a little bit inducing randomness and making it less deterministic in nature. We hope we've been able to demonstrate a novel method for macro information creation that is built on solid scientific data. Also, we also hope we've demonstrated a novel policy strategy formulation on the method that is in sync and does interact with other factors. Also, identified innovation macro policy strategies and emerging behavior that are in line with initial conditions. ABM may aid in insight and contribution to the field of multi-facet policy creation and phasing. While the study focused on demand and supply side factors, imperative additional work required on the environmental side, such as structural rigidities, for example. Work on scaling mechanism is also essential for validation purposes. if to utilize this model approach in a practical environment. ABM is instrumental in contribution to the field of multi-phased policy creation and time phasing. Innovation is a global competition. Skilled labor attainment is perhaps the most pressing policy for innovation. Emerging behavior of policy may become counterintuitive if initial conditions are not considered and factored in. Once again, I would like to thank you for joining me in this presentation, and I hope that you have found it to be inspiring or useful in your scientific pursuit. My information are found below and my website, so please feel free to send me any inquiry you may have. And if you want a copy of the NetLogo model, I'll be more than happy to share it with you. Just send me your information so I can build up a network of experts in this field. So I look forward to interacting with you, and I look forward for future collaboration on any project of similar nature. Thank you very much, and have a good day.